Alright, in this video we're going to take a look at topic 5, which is factoring and completing the square. We're going to see completing the square twice in this review. This is the first time we'll see it, and we will see it again later for another quick review. So here we are with question 14. We are at a swim meet and Dylan dives from a diving board, and this equation here, h of t negative 2t squared minus 7t plus 25, represents his height above the water, his position. So t is measuring seconds and h of t is talking about his height in meters. Part A is asking us to figure out what this h value is. It says that Dylan is investigating the time it takes him to get to the water, and he's using completing the square. So Dylan has jumped from this original equation to this equation using completing the square, and what we're missing is the h value, which is inside with t inside the parentheses being squared. So in order to find out what that value is, we need to do the first 3 steps of completing the square. In the third step, we'll be able to figure out what this h value is. So we're going to begin with the original function, and we're going to start with the first step of completing the square, which is to move c to the other side of the equation. So right now we have negative 2t squared minus 7t plus 25. We're going to make this equation equal to 0, just so we have somewhere to move our values when we have to do our moving steps. And c is the third value. We have a in front of t squared, b in front of t, and c is the value by itself. So we're going to move that to the opposite side of the equation by subtracting 25 from both sides. So negative 2t squared minus 7t, and we're going to subtract 25 from both sides, so it's going to equal negative 25. Excuse me. Now that we've done that, we're going to go ahead to step 2 of completing the square, which is to factor out our a value. Remember, a is the value in front of the squared term in the front of our equation. So we're going to factor out this negative 2 from the left side of our equation. So we're going to move it to the front, and we're going to take all the terms on the left side and divide them by negative 2 in order to do that factoring. So if I take my negative 2t squared and divide out negative 2, I just get t squared by itself. And then we're going to take negative 7t and divide out negative 2. So the negative divided by a negative will give us a positive, and 7 divided by 2 is just 7 over 2. It's a decimal, so I'm going to leave it as a fraction. And there's the t. So we didn't take out our GCF. Notice the t's are still in there. This step is not to take out the GCF. It's just to factor out the a value. We need the extra t in there for the third step. The rest of the equation is exactly the same. We're not going to touch the right side. That's the point of moving it away, so we don't have to worry about it. And now we're ready to go on to the third step of completing the square. So the first step is to move c, the second step is to factor out a, and the third step is to take care of what's inside the parentheses here. We're going to rewrite this portion of our equation as a completed square. So the negative 2 in front will not change, and the negative 25 on the other side of the equation will not change. But what we're going to do is rewrite this portion. We're going to move this squared to the outside of our parentheses, and we're going to take this t and write it by itself in front. And what we're going to do now is we're going to take this b term, and we're going to have to divide it by 2. So it's positive, we'll keep it as a plus, and we need to do 7/2 divided by 2. So we end up with x plus b over 2 inside our parentheses being squared. So here's our b term, 7/2. I need to divide that by 2 to get the number that goes inside the parentheses with t. Now the easiest way to complete this part of the step is to just use keep, change, flip. So keep the top the same, 7/2, change the sign to multiplication, and flip the bottom upside down. The bottom is the number 2, which is a 2 over 1. I'm going to flip it upside down by making it into a 1/2. Now I can see that the number that goes inside the parentheses is 7 over 4. Now, this is going to be our answer, but we have one more thing to take into account. What you'll notice here is what we're looking for is the number inside with t in the parentheses being squared, and here you can see inside with t, the number inside the parentheses being squared is that 7/4. The last thing to consider for this problem is that there is a minus sign inside this equation on the left, and we have a plus sign over here. So we have one last thing to do, and that's to figure out what number is being subtracted when I get a positive 7/4. So I need to take this portion, positive 7/4, and I need to rewrite it as t minus a number in order to figure out what's being subtracted. So we have 7/4, and in order to create a positive, I must be subtracting a negative. If I subtract a negative, it turns into a plus symbol. So the actual h value is 7/4, but in order to get the proper plus sign, I must be subtracting a negative. So h, I'm going to write it down here, is negative 7/4. And that's it for that step. We just had to do the first 3 steps of completing the square. Move c to the other side, factor out a, and then rewrite the parentheses as x plus b over 2 with the squared on the outside. So in this case, t plus 7/4 with the squared on the outside. All right, now we're ready for part B. How much time does it take Dylan to enter the water after making the jump? So for this one, we're actually looking for the value of t, and now that we found h, we can complete the equation that they gave to us. We don't have to worry about simplifying the rest of the formula we've got with the negative 25 and the negative 2, and we didn't actually even have to do step 4 of completing the square because they finished it for us. They told us that t minus the h value squared is this number, 249/16. They already simplified everything else for us, and if you'd like to, you're more than welcome to try to use completing the square to get that same answer for practice. You would have to end up doing the 4th step, which is to add a times b over 2 quantity squared to the right side, and once you simplify those fractions, you'll come up with the same number that they did. But instead of worrying about that, all we really have to do is plug in the h value we just found, which is that negative 7/4. And all we have to do here is solve for time. How much time? So we're going to be looking for the t value right over here. So all we have to do is solve this equation for t. Let's go ahead and take a look at that. So this is t plus 7/4 squared, and it equals 249/16. Now our job is to get t alone. So if we take a look at what's happening to t, we're adding 7/4 and then squaring. So we're going to have to square root and then subtract. So we're just going to have to undo the things happening to t in the opposite order. So our first job is going to be to square root both sides. We're going to go ahead and add a plus or minus here because we are putting the square root into this problem. So t plus 7/4 is going to equal whatever the positive or negative square root of 249/16 is. And it's asking for a decimal, so we're going to plug this in the calculator to find our final answer. And then our last job is just going to be to subtract that 7/4 from both sides. Minus 7/4. Here we go. So let's see. So we end up with t, which is going to be equal to either positive square root of 249/16 minus 7/4, or it could be equal to negative square root of 249/16 minus 7/4. Now, the only problem with that is that what we're asking to solve for here is time. So I want to take another look at the positive or negative solutions here. If we get a negative solution, it means that it takes him a negative amount of time in order to reach the water. But we only measure time going forwards. We're not going to expect Dylan to travel backward in time in order to get to the water. So because we're not going to be using negative time, even though positive or negative makes sense theoretically, when we actually take a look at the context of this problem, negative doesn't make any sense at all. So we're actually only going to be taking the positive square root here. So all we have to do is plug that in the calculator, the square root of 249/16 minus 7/4, and when we do that, it tells us that the time is 2.2, rounded to the nearest tenth, and that means it takes him 2.2 seconds to hit the water. Now it doesn't ask for units, but if it did, we want to make sure that time is measured in seconds like it says in the original problem. All right. That leaves question 14 finished. Let's go ahead and take a look at question 15. 15 is going to ask us to use some factoring. Now there are lots of different types of factoring happening here, so let's take a look at the first problem. There are lots of ways to factor. In this problem, 4x squared minus 9 equals 0. We have an a value of 4 a c value of -9, and there's no x term in between them, which means we have a b value of 0. So you can use traditional factoring here with a t-chart, but you would have to use fake factoring. In order to fake factor, let me just go ahead and show you how to do that. In order to do fake factoring, we have 4x squared plus 0x minus 9. To do fake factoring, remember what you have to do. Make a t-chart. We're going to start by multiplying a by c. We get -36. And we want two things that multiply to -36 and add to the b term in the middle, which is 0. So we would want to find the two factors of 36 that multiply to a -36 and add to 0. Because it's -36 that they multiply to, they do have to be opposite signs. And the two numbers that multiply to 36 that are opposite signs are -6 and +6, and they combine to 0. So we would be able to start factoring using that. We would have to put ax in both parentheses. A is the number 4, so we'd have to put 4x in both parentheses, and the -6 and +6 we just found. But these factors are a times too big, so the last step is to divide a back out. We have to divide by 4. Now, neither one of these can be divided by 4 evenly, with 4 as a whole number, so what we can do is break 4 into pieces. We're going to break it into its factors, 2 and 2, and divide them out one at a time. So we end up with 4 divided by 2, which is 2x, and 6 divided by 2, which is 3, so 2x minus 3, and this side would give us 2x plus 3. And now that's completely factored using fake factoring. Now, if we wanted to do that faster and more efficiently, we could also notice that 4x squared is a perfect square and 9 is a perfect square, which means that we can use difference of squares here, which is much faster. So let's go ahead and try that. To use difference of squares, all I have to do is figure out what's being squared in front, and the thing being squared in front is 2x. 2x times itself is 4x squared. And then we find the thing being squared in back, which is the number 3. 3 squared gives us 9. And that immediately tells us how to factor. If I can find what's being squared in front and what's being squared in back, all I have to do is put them in parentheses, 2x and 2x, and we do plus 3 and minus 3. So that's our shortcut there. And you can see we get the same result, but we get it much faster without having to fake factor. So if you notice two perfect squares with a subtraction between them, there's a very, very efficient shortcut to finding the factored form. Now all we have to do is solve. It does say in the problem we have to solve, so we have one more step to do. No matter which way we factored, we would get the same factors here. Last step is to set them equal to 0. So 2x plus 3 equals 0. We would have to subtract 3 from both sides. 2x is -3, and then divide by 2. X is -3 over 2. We can do the same thing for this factor. 2x minus 3 equals 0. Add 3 to both sides. 2x is 3. And divide both sides by 2. X is positive 3/2. So I have these two answers for my first equation. All right, let's take a look at my second equation. For my second equation, I have 24 is x squared minus 5x. Now, the whole point of factoring is to find the factors that I can set equal to 0. So I could try to factor the right side of this equation, but I wouldn't be able to set my factors equal to 0 because the left side of my equation is not the number 0. The reason I could do that on the first equation because it was already set equal to 0. Now, the first step should always be to get whatever you want to factor and set it equal to 0. So the first thing we're going to do is move everything to one side of this equation so that we can set this equal to 0. So we're going to take the 24 and move it to the right side of the equation. We're going to subtract 24 from both sides. And that should read minus 24. Here we go, minus 24. We end up with 0 is x squared minus 5x minus 24. All right, now we have everything on the right side of the equation. We can see that this is a quadratic, and we factor a quadratic using a t-chart. So let's go ahead and take a look at using a t-chart here. We want to find two things that multiply to the c value, -24, and add to the b value, -5. Now, if I can't figure out what those two things are just by looking, that's fine. That's why we make the t-chart, because in the t-chart I can make a list of factors. So 24 is 1 times 24, 2 times 12, and we keep running through the numbers here, 3 times 8, and 4 times 6, until we find the things that will give us the number 5, either through addition or subtraction. Since we're multiplying to a negative number, we're looking for things that subtract to 5, and that's going to be the numbers 8 and 3 right here. In order to get a negative 5, the negative has to be the larger number. So 8 has to be negative, and 3 has to be positive. And we can put our x in the front of each one, and these are our factors. Now the last step is to set these equal to 0. If I set x minus 8 equal to 0, x is 8. And if I had set x plus 3 equal to 0, x is negative 3. So we have our two solutions here. All right, we've got one more to solve. Let's go ahead and take a look at what's happening with problem C. Now this is already set equal to 0, which means I can go ahead and start factoring. And as you can see, it's not a quadratic. I have 2x cubed, which means I should have 3 solutions when I'm done with this. And in order to get started with factoring, I have to remember the very first and most important step of factoring. We didn't do the first step for A or B because it wasn't necessary, because we didn't have one. But for problem C, I can see very obviously by looking at the x here, the x here, and the x here, that we have a GCF. So our first step is going to be to find the GCF. Now x goes into every single term. I can also see that every single term is an even number, so 2 also goes in. So my GCF is going to be 2x, and I'm going to want to remove that and factor that out from every single term. So I'm going to bring the 2x to the front, and let's see what's left over once the 2x is gone. So if I take 2x cubed and divide 2x away, I'll only have x left. Just kidding, x squared. There we go. If I take my negative 16x squared and divide out 2x, I'll have negative 8x left over. One of the x's goes away. And my last term, positive 24, if I divide it by 2x, I'll have a positive 12, and the x will be gone. So here is my GCF factored out. Now we want to make sure to keep it in front. It doesn't disappear. Factoring does not actually eliminate anything. It just moves it around. So the 2x goes to the front. Now that the 2x is in the front, I'm going to be able to factor the rest of this quadratic here using a t-chart. Oh, thank you very much. So I want to find two things that multiply to 12 and add to negative 8. That's an 8. There we go. So the numbers that multiply to 12 that add to 8 are going to be 6 and 2. So I'm going to use my parentheses here. We're going to have an x, and a 6, and a 2. In order to get a negative 8 and a positive 12, the positive 12 means they have to be the same sign. So to get a negative 8 when I add them, they both have to be negative. And I want to make sure to bring that 2x back down to the front. All right, so 2x times x minus 6 times x minus 2. These are all of my factors. To finish this problem, I want to make sure to set every single factor equal to 0, every single one, and I have 3 here. I've got 2x. I'm going to set that equal to 0, which gives me x is 0. 0 divided by 2 is just 0. Then I have x minus 6 equals 0, so x is going to be 6. And I have x minus 2 equals 0. Oops. Having a hard time here. And x minus 2 equals 0, so x is going to be the number 2. So I have 3 solutions here to this problem. X is 0, x is 6, and x is 2. Let me rewrite this 6. There. Beautiful. All right, so we have all 3 solutions. Remember, the degree of your polynomial will tell you how many solutions you're going to have. So my first 2 were a second degree, so I had 2 solutions each. My third one was the third degree. I should have 3 solutions. It's a good way to check your work. All right, we're going to cover topic 6 in the next video.